Excuse me. We're gonna get started, if that's okay. I know the bar is like live, so that's good. But I just want, first of all, I want to introduce myself. I'm Sanjeev Lal, and I wanted to thank you guys for all coming tonight. What a cool event. You guys are awesome. There's a lot of places to be tonight, so I appreciate you guys being here. We have a lot of stuff that we're going to be discussed. We have some great panelists, some great guests, but I wanted to start by introducing Ashley Kahn from Beverly Hills Magazine, and she's going to start doing some introductions for us. So here you go.
Hi, thanks so much. It's an honor to be here. My name is Ashley. I'm the publisher of Beverly Hills Living Magazine, and as the only resident exclusive publication in Beverly Hills, I take great pride in the material that goes out to our readers. So to witness a panel of this caliber, not only making a difference, but educating and enlightening is a true gift. So with that being said, I would like to present the Welcome to LA Award to Sanjeev. Congratulations on Beverly Hills Rejuvenation Center.
That is good. I didn't even win it. It's an Academy Award. That's awesome. So I appreciate that. That's so nice, and thank you. So I am in transition to LA, and that's awesome for us, and it's very exciting. But the one of the cool things that we're doing tonight is we're talking about longevity. We're talking about healthcare. We're talking about all the innovation that's happening in the space. And we have such a great panel to discuss, but we also have great leaders in the room too. And I'm kind of honored to be here because when you think about, as an outsider coming into LA and coming into Beverly Hills, you get to see this is the epicenter, the global epicenter of where healthcare has always taken place, at least in our eyes, right? And where technology is kind of led on the forefront, where there's been entrepreneurs and leaders who've kind of driven that innovation and technology. And so I'm super honored to introduce Fiona Ma, our state treasurer of California. And so I got to meet her for the first time a few months ago at an event like this. And when she talks about innovation, she talks about the technology, this hits home. And we've seen people leave California, and now we're seeing people come into California. And that is really our excitement. So it's my pleasure and honor to introduce our state treasurer and next lieutenant governor, Fiona Ma, to the stage. So I appreciate you.
Thank you. Thank you, Sanjeev. And I want to thank my good friend, Dr. Kate, for bringing us all together and just introducing me to so many cool people and cool things that everybody is doing. I just want to thank the people of California, the voters, for being so generous. Every couple years, there are initiatives on the state ballot. And because of that, California has passed 3 children's hospital bonds. And therefore, our children's hospitals are the best, bar none, around the world, right? Anybody use our children's hospitals? California's also passed 2 stem cell research initiatives. Back in 2004 for $3 billion in general obligation bonds, and then in 2020, $5.5 billion. That's $8.5 billion. There is no other place in the world that has passed this much money into research, grants, facilities, patient therapies, research training, clinical developments. And that's why I think all of us are here. Because of the ecosystem, because we can find funding. And as the state banker, I take in over $3 trillion. I have a short-term portfolio of about $165 billion. I manage all the bonds, including all the children's hospital bonds and the stem cell research bonds. And then I fund and finance everything from housing to schools, to public transportation, green energy, small businesses, startups, advanced manufacturing. So if any of you need money, please come see me after. So just a little story, right? Today I was speaking in Sacramento to a bunch of CPAs. I'm a CPA, and they always ask me to come and just give a little, rah-rah to CPAs who are going to Sacramento to lobby the members of the Assembly and the Senate. And so after I gave my, hey, this is the state of this, the state, and, is it too expensive to do business here? Yes. Are the taxes too high? Yes. What is it that we can do? Blah, 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 blah. And then they opened up for one question. And this one Asian woman in the back, she goes, you know what? Something you said made everyone at my table go, what? And I go, okay, what's that question? What have you doing to your face? That's the question. I'm gonna be 60 next month. And I was like, that's the question that you have for me? Okay. So, I was preparing for tonight, so I kind of knew what to say. And so I was saying, hey, for many, many years, I've been using Botox. It only lasts, every 5 months. Obviously, chiropractor has been very, important to me. And then I got menopause 7 years ago, and so I had a hard time sleeping. I had hot flashes, so I've been doing gummies. And then most recently, I've been doing I did this body scan, and then they customize these supplements, with multiple active ingredients. So I do those. And then I do glutathione with Dr. Patel. Where's Dr. Patel? He's going to be here on the stage. This has made a huge difference because I have ailments all the time. I'm traveling, my elbow's hurting, my back's hurting. Sometimes I hurt my feet, and then I just rub a little bit, and all of a sudden, next day, it's gone. And then he told me he's got this copper peptide, so I can't wait. Put it on your face, maybe my face will look even better. So look forward to that. And then acupuncture. I've been doing acupuncture on my face, believe it or not, to break up the cells. Because like kids, their face is always growing, but as adults, they kind of get stuck. And I think that's made a difference. And then using NADH plus B12 shots. I've done 20 of them, and energy, I feel like I've changed. My skin has changed. I've gotten rid of all my age spots. And then recently, hyperbaric chamber in Hollywood with one of our friends, Charles Liu. So all of these things, I think, are working and helping. As all of you know, we all want to look younger, right? Mother Nature can only do so much. And so tonight, I look forward to hearing about all the new, latest, and greatest with all of these amazing entrepreneurs. And it is just my pleasure to be here to give a couple of certificates of recognition to these amazing leaders. Thank you for keeping California golden. Today, people mentioned Texas 4 times. I am getting twitches every time I hear Texas, right? Who wants to go to Texas? No, we all want to stay here. And so part of my job is to make California more business friendly, more tax friendly, the ecosystem better, so that we all feel comfortable, want to stay here, grow here, and promote California. So thank you all. Okay, so Sanjeev, Dr. Irina Conboy, please come to the stage. Dr. Daniel Pompa, Dr. Nayan Patel, Dr. Ashkan Gavami, and Dr. Kate. Please come to the stage.
You got a shout out on the glue. Oh, yeah, pretty good.
She does want me to read it, so on behalf of the state of California, I hereby award the certificate of recognition in honor of your exceptional leadership and outstanding contributions to the advancement of regenerative medicine and longevity. Thank you for your unwavering commitment to pioneering integrative approaches that elevate patient safety within the Golden State. I need some eye stuff. Eye regeneration. So, anybody got any? Okay, Doctor. Thank you.
Sure.
Take a picture.
Well, this is a true honor. Thank you so much. State of California is, the only state I've really ever lived in. I was raised here in Los Angeles. Taxes are high. Other than taxes, though, this is, I think, the best state in the entire United States for multiple reasons. And, hopefully, California leads the way in some of the research on regenerative medicine, peptides, et cetera, because a lot of the research we have on peptides is animal-based, we don't have a lot of human studies. So it would be good to see, we have Palo Alto, we have so much big money in Stanford, and we have Caltech, we have all these institutions, greatest universities in the entire world in this one state. So I'm sure if we get that done, it'll be amazing. I believed in fat transfer since day one. I was one of the first to do fat transfer in Los Angeles, to the point where I had plastic surgeons kind of walk by the OR and be like, what is he doing putting fat on the breasts and the buttock? Like, it was so controversial back in 2007, 2008. And a lot of the doctors that are known for it now were still in med school and high school then. So it's really grown. It's an accepted modality now. And I chair the SD Arts meeting every year in San Diego around August time, where we talk about nano-fat injections and all the different peptides. And really, there's so much in society right now that's becoming degenerative with doom scrolling, bad social media. Just people are inundated with things. And so because of that degenerative type of propagation in society, I feel like we have to do regenerative. It's our duty to do it as physicians. So thank you very much.
We're all going to talk on the panel. So just say
Thank you.
I wasn't prepared for this one, but thank you for this award. I really appreciate that part. I've been working in the state of California since I graduated from California. So I've been here for over 30 plus years. And as a pharmacist, I have seen completely change how we prescribe medicine. Because until today, all the medicine that's supposed to do is to take care of the symptoms. But I have taken a second leap of faith, is that I'm here to solve people's problems. I don't want to prescribe medications anymore. So we've been working on some technologies very early on. I was researching for stem cells back in early days for some prostate issues. We moved on from stem cells to the peptides back in early 2000s, when we used to call them hormones. And now we call them peptides. But then because of that work, I was able to work on some peptides today. So we are here today. But this state is probably the best state to work in because of the leeway we get early on to do this work, and then other people catches on to it. So thank you for doing that. Thanks for allowing us to be here.
Let's take a picture. Yes.
Since you pulled it.
Yes, good call.
Okay, so thank you guys so much. Dr. Pompa, Irina, and Sanjeev stay. Thank you so much, Fiona Ma. Thank you, everyone. So hi, for those of you who don't know me, my name is Kate, and I'm really honored to be here. Like Sanjeev said, so many people in this room could be on this stage, so we're grateful that you're listening to us talk right now. And I really want to make the conversation informative about some new innovations. And I would like to start by thanking Sanjeev and his quantum regen therapy cell factors is behind the stage. So something we're going to really focus on tonight is cell signaling, which is a focus of both Irina and Dr. Pompa's work, and now Sanjeev's work. So Dr. Pompa, would you like to start us off by talking about the cell and why signals matter?
Gosh, I'll bore everyone to death if I just talk about the cell. Can't do that, but fix the cell, you get well. That is my saying for many, many years, and it's true. If your cells are healthy, you are healthy. But what does that actually mean? I can say this. This is an exciting conversation because I've been in the regenerative world now since I was 51. I'm 60. And like many people, my injuries from my past caught up to me. And all of a sudden, I had back pain instead of like once in a while, it was 4 times that year. And all of a sudden, my neck that I broke wrestling, I couldn't even turn. So these things started happening. Torn meniscus. I wasn't getting surgery. And I started my research into stem cells. And that led me through a lot of discovery and being here on this stage. So you're going to learn, hopefully, everything that I've learned. And some of this new technology really excites me. because it's the future. So you're in the right room. If you care about your health and you care about aging slowly, you are in the right room. You're going to hear information that you never heard before. And, you know, believe it or not, when I have conversations about stem cells with people, you know what they say? Oh, that's legal still, right? Because especially people more my age, because we go back to Christopher Reeves and they think, oh, yeah, because all that controversy and, you know, they don't even know that they're legal. However, you're going to just hear something tonight very different than stem cells, you know, but I think on the same path as far as what stem cells have done for me, changed my life. And by the way, 60, no back pain. My wife and I have never had Botox, and we don't do fillers, we don't do anything, but we do stem cells on our face. And she's done cell factors, and that's really what you're going to hear a lot about. So this is an exciting conversation, but I will say this to open it up. You can determine how healthy someone is, and there's a saying that life and death begins on your cell membranes. And I can say this, your hormone health begins on your cell membranes, meaning you could have perfect hormones on your blood or even make it look perfect by taking hormones and look at your blood and say, wow. And people will say, yeah, but my hair is still thinning. I still can't lose weight. I still don't feel well. I still have brain fog. See, because those hormones, they don't work in your blood. They only work in your cells. They have to connect into cells via receptors on your cell membrane. And the healthier that is, the more hormone sensitive you are. And therefore, you don't even need super high levels of hormones. Your body hears them, your cells hear them, and you're healthy. Cells communicate with cells. And you're going to hear more about that tonight from the stage. I'm honored to sit next to you because, and I'm going to pass the mic to her because she did a study that I read years ago that excited me. 2 rats were sewn together. And it wasn't even until recently that I even knew that you did this, but 2 rats were sewn together, a young one and an old one. Guess what happened because of cell signaling and cell factors? The old one became young. And that was this research. So a lot of what you hear tonight started right there.
Yeah, thank you so much. Great segue. So they were mice, they were not rats. But the whole point is correct. So if you guys know about the sitcom Blood Boy, it actually came from the discovery of the Conboy laboratory. And when many people interpret this experiment, they say, hey, we have something in the young blood, right? So if you connect an old mouse and a young mouse, and they share blood for some time, and they also share internal organs and environments, guess what happened? Do you have 2 young mice, 2 old mice, or 2 middle-aged mice? You have youth and an old age, and you connected them. So what happens is that the old mouse becomes much younger very quickly. But even more importantly, the young mouse becomes old. And people overlook that, and therefore what they were doing for the next 20 years was somewhat erroneous. Because if you think about it, if you start with a brand new organism that has long telomeres, nothing is wrong with the mitochondria, and it still has 50% of young blood, and you give that organism just 50% of old blood once, it becomes old. Guess how quickly? Guess how quickly? You have 2 weeks. In 2 weeks, brand new young animal becomes old and senescent in brain, in cardiovascular system, in liver, in skin, in bones. So on one hand, you say, wow, that's not very good. But on the other hand, it's wonderful because it means that aging is not just progression of time. It is time-independent process. And when you're systemically old, you are immediately old. So then the question is, can we rejuvenate your systemic or blood milieu or circulation? How can we do that? So then the answer was, yes, we can. And then in 2022, we published a study were using FDA-approved therapeutic plasma exchange, people who were already in their 60s and 70s, after paying loads of money for rounds of procedure, became much, much younger. They did not get any young blood, no, zero young blood. What happened, we diluted their old plasma. And it turns out that aging is actually in excess. We do not get old because we lose a vitamin. We get old because we start overproducing a bunch of proteins everywhere in our body, and then the proteins aggregate and cause diseases like Alzheimer's and so forth. So for the first 20 years of my career, I was professor, not for the first 20 years, but intermediate 20 years of my career. I was professor of bioengineering at UC Berkeley, and we published all of this work on how to rejuvenate mice. But of course, mice are not little people. We need to, to figure out how to rejuvenate people. And so in 2023, I co-founded Generation Lab, a company that is going to translate all of the scientific discoveries of the Conboy Lab and make them physically possible to do them in clinic with the help of all of these guys.
Awesome. Thank you so much, Irina. So Sanjeev, so the reason, part of how we came together is, and Sanjeev is going to tell us now about cell factors, and we are working with Generation Lab to show how cell factors work and that they work. And we'll get into that and we'll show you Dr. Pompa's test. So that's basically the intention of this entire panel. But Sanjeev, could you please?
Yeah, so I mean, I agree with everything that everyone's saying. It's about cellular communication, it's about this, but it's really about cell signaling, right? What happens when we get older is we lose our signaling system, right? And our cells stop receiving and sending these signals. And these are youthful signals that we kind of slow down around 18. They kind of take a massive cliff dive around 28. And our cells start to leak things like mitochondrial DNA. And when it starts to leak these things, our body starts to attack it, like Irina was saying. And so we're like, the synergy on that is so strong. And so what have we done for that last 15 years is add shit to our bodies instead of fixing the problem. And so that's what I love. And that is the problem that we need to we solve for. And so it's resetting our cell signaling and figuring out why we are leaking these things out of our cells. So it's about cellular aging, not your chronological age or biological age. It's about your cellular age and which cells are leaking what and why are they doing that? And why does our body attack them, right? And so it's attacking itself. And it's creating this inflammation, which is why we age. It happens in the brain, it happens in our organs. And so it's because our youth signals go away and they come dormant. Our cells don't, they just stop listening. Right? And so what RegenQuantum Cell Factors is, it's reintroducing those youth signals into the body. It's not an additional cell to the body. It is stimulating your cells to signal and your other cell to receive that signal by not penetrating the membrane, but by signaling to the surface of the membrane, because it's a code. It's an instruction code. We were born this way. It is native stem cell signaling. We heal ourselves. We have the ability to do that all throughout life, and then we start aging. And so that's the differentiator of what we're doing versus stem cells and exosomes, even though they have great products. They're great products. You need them in certain scenarios, and you need them in life. But when you're 28, 29 years old and your signaling starts to slow down, let's start reintroducing that back into the system. Right? So then maybe we don't need stem cells when we're 45, 50, 60, 80 years old, right? Our signals listen to us. We've shut them off because of the foods we eat, the sedentary lifestyle we have, the things that we put in our body, the high stress that we live in the environment. And the change in this is quantum, right? We've talked about it. You guys you've probably tried or heard of stem cells. You guys have all tried or heard of exosomes. But those are all derivatives of umbilical cord or Wharton's jelly or something like that. Well, that's not what is the entire regenerative process. You were created by a placenta, the whole placenta, not just a part of it. And so the idea and concept with quantum is we are placentally derived cell factors, but we're DNA free and acellular. And we do that because we let in the lab, we let the cells excrete and then secrete, and then we isolate the messages, and they're native cell messages, and they go back into your body, and your body doesn't attack itself. It recognizes them as normal because we've had them since we were kids, right? And so that is really the definitive approach that we're taking, and why we're launching in California, why we're launching in Beverly Hills, why we're here tonight, is to not talk about adding stuff to our bodies. It's about returning our bodies back to when we were younger. And so that's the exciting part.
Amazing. So Dr. Pompa, you've had an opportunity to both take Generation Labs test and also use cell factors. So I was hoping that you could talk a little bit about your experience. And also, Alec, if you could put his report on the screen.
You know, one of the things that has been really cool, like you said, you know, there's a place for stem cells still, and he can explain that. But when I started getting stem cells, obviously repair started happening in my body. It was using a lot of signaling that I, was lacking. And my vision started getting better to the point where I was telling you the story last night, I was forgetting my glasses everywhere. And I kept thinking, it's right, it was happening. I was overly prescribed. I didn't know it. And I kept setting them down, saying, I had this beautiful glasses collection. I loved my glasses. And I was forgetting this. So then I realized, oh my gosh, my vision got better. It was a lot of the stem cells I was doing. And so I spent all this money and I got new lenses. And then what happened was I got more stem cells. And it happened again. So then I just recently, when I got the cell factors, it happened again. So here I am. This eye is 100% corrected. I have perfect near vision at 60, but more importantly, I have my far vision back. This eye is not perfect, but since I had the cell factors, I'm like, here we go again. So thank God I didn't spend more money on lenses. But so it literally is turning back the clock.
And what does your test say about your eyes and your? Can you talk about?
Yeah. So here's the test, right? Yeah. So.
And Irina, feel free to.
Yeah. Go ahead. Just tell them what's going on.
Actually, maybe I will introduce the test first. What to talk about?
Oh.
Yeah, sure. So the test of Generation Lab is science-based, and we identified 460 genes out of 500,000 or a million genes that are critically vital for your youth and your health. So we screen them on thousands of people who are different ages, and some are healthy and some have different diseases. So these genes become noisy. They have not yet reached the situation where you are clinically in the pathological range. You are not there yet, but they are trembling. So they are experiencing biological entropy. They are now stochastically vacillating because the problem is brewing. You are still pre-symptomatic. We can cure you much faster. So this is our test. We tell you what is the degree of biological noise in the genes that are critically vital for the health of various systems in your body. Which system is dragging your biological age upward and how fast? And if you are doing stem cells or exosomes or any treatment, does that system goes back to the levels like when you were 25 years old? This is our test. This is absolutely scientifically based. It is not a model. We do not transform data in biologically arbitrary way. We are simply quantifying it. It's literally how if you try to lose weight, you step on a scale and you see a number. And what we did, we discovered the scale, and we discovered, metaphorically speaking, that there is gravitational force, and the more you eat, the higher your mass is. So it is that science-based. There is nothing getting out of it. So if for you, your biological age is now younger, it is truly younger. It's like stepping on a scale and measuring your weight.
Yeah, I mean, I'm almost 6 years younger in total of my age on this test. Interestingly, that when I was sick, I started out 11 years older at my cellular age at one point. Not on this test. This was using telomere testing and DNA methylation. And then through the process, I've gotten younger. I mean, because I was very sick for many years. It made me more, I'm older at the cellular age than my actual age, 11 years. And then I swayed it on telomere testing by 9 years, the first test. And then the second one was like a 14-year sway. This test is more accurate. Much more accurate. I'll let you describe, I'll let you say. So this test is more fine-tuned to DNA methylation and telomere testing. Explain.
I don't want to, occupy lots of space. Do you like Sanjeev? Yeah. So basically, telomere test is not a very good test because we shouldn't have long telomeres. That is actually predisposition to cancer. So nothing is good about having long telomeres in your blood cells. Blood cells on purpose should not have telomerase and should not have telomeres because every time you have an infection, you actually have many, many more cells produced. So one cell divides, has millions of cells to actually kill the bacteria or virus or cancer cells. They do not have very good DNA repair, and they have a tendency to turn into leukemia and lymphomas. Not having telomeres protects you from blood cancers because when they keep dividing without telomeres, they eventually will die. So I think that telomere is a misconception. It's an exception that proves the rule that in most of our bodies, cells do not divide and do not shorten their telomeres. Our test is basically based on the hypothesis that if you look at the genes that have almost the same DNA methylation when you are 25, when you are over 70. So we try to keep DNA methylation constant throughout our lives because those are critically vital. If we change their methylation, we are in trouble or dead. We pick every one of those genes. They are critically important for us. And they start to be noisy. That noise signifies your age. That noise happens before you have a disease, and we can simply sum up the metrics, such as cholesterol, blood pressure. That noise is the very, very early warning sign, like you drive a car, you hear a noise. You don't know what is breaking, but you know it's not good, right? So you take it to a mechanic. Mechanic will tell you the noise comes from this part of the car. This is a good analogy of the test.
Yeah, go ahead.
I was just going to say, the accuracy of that was, so my muscular system was my worst, but I did work out that morning and that could have thrown that off. Yeah, so I screwed that up. I didn't listen. Kate told me not to do that. But it said like my tendinopathies started occurring literally a year ago where I was getting different tendinitises, et cetera. It showed up on the test as really the biggest issue that I had. I mean, it was so accurate. I mean,
It's not correlated. It's causal.
yeah, causal for sure.
No, but the point is like I think what we're saying is we need to start measuring what we're doing. So these are protocol. We do protocols in the clinical space all the time, and we just do it by outcomes based on looks and feel, and we don't measure anything, and we don't have sustainable longevity protocols in the system because we continue to add more protocols to the thing because we think that's better for you in the long term, right? So let's just add more things to it, and maybe that'll be better, and maybe I'll look or feel better. And so having measurable, sustainable protocols makes longevity sustainable. And there's a longevity space that's going to be here for 120 years, right? So if we don't measure, then we can't really test the results of what we're doing. If we don't have protocols, we don't know what's actually making these changes happen, right? So when we use cell factors or we use quantum in the space, we are partnering with Generation Lab to show you your system's aging goes down because you're introducing cell signals to your body, right? And then if you want to add on hyperbaric oxygen therapy, you want to do infrared, or you want to do red light therapy for this. Those are great modalities, but let's fix the problem. Yeah, we don't know yet, right? So let's measure them.
And
By the way, this was before I did the cell factors.
Yeah.
So now we're going to do a retest.
And so what did you do with the cell factors?
Me? Mm-hmm. Yeah, I did a push with him. And then I had my shoulder injected, which, interesting, because when people get stem cells, sometimes they leave with this immediate de-inflammation and they go, oh my gosh, I'm better. And I'm always like, whoa, whoa, whoa. Remember, they're turning on healing in the body. Typically, you don't notice anything till about 8 weeks. And literally around 7-8 weeks, I said to my wife, oh my gosh, I literally can push dumbbells over my head again, and that happened around the 7-8 week mark. So, which was, I'm going to say though, it was a little faster than stem cells because stem cells typically took me 3 or 4 months before I would actually have a result. And people don't understand that about stem cells. It does take time for the result. My wife got them done on her face, noticeable difference in literally that 8 week period of time. So, again, it's not an immediate thing. This isn't Botox where you walk out looking different. it takes time because you're driving that healing process. So keep that in mind. But that's what I got done.
Yeah. So one thing I'd love for Sanjeev to explain is how you get cell factors, like how you get them from the cells and what that looks like, that process.
It's so I mentioned it a little bit. So we have a single donor. So we don't use multiple placentas. We're not going through them all. We have a single donor. That she was 18 years old. She's from a rural part of Alabama. She had a girl. She had microplastics before.
And by the way, this was my question. I wanted to make sure she wasn't COVID vaxxed. I wanted to make sure, I went through a litany of questions because.
Yeah, so we use AATB accreditation, but then we, on top of our own higher standards, we don't use adult vaccines and we don't use any microplastics higher than 50 nanometers in the body. And so microplastics interfere with cell signaling equally as bad as your COVID vaccines. And so so when we got that donor, that's really when we started making a lot of product. We cryopreserve those cell lines. It's a single donor. So when we do that, we take the placenta. There's 6 regenerative properties of the placenta. We map those 6 regenerative properties to what the NIH has told us is those gene expression pathways. There's 312 of them. And we map towards those. We do protein testing. We do cytokine testing to make sure that the gene expression markers are being turned on or turned off in those scenarios. And then we isolate them through secreting them. So we suspend them in these bioreactors, not through cell expansion, but through cell isolation. We let them secrete these vesicles into the body or into the in vitro, and then we pull them into the medium. And so now we have a product that is DNA-free, acellular, it's pure cell signaling, it's cluster cell signaling, not single protein cell signaling like a peptide. It is a global reset to your body. And so the inflammation that you were talking about, you feel it immediately go away because it's honing that in. But over time, you're going to see your systems age scores decrease because you're reintroducing cells, not live cells, cell signals to your body. You're not permeating these cells, and you're getting the action of occurrence that's happening is your body is responding to it much quicker because it recognizes it as native, because it is a native cell signal. It's what your body has turned off as you aged. So that's how we use the product. That's how it came to be. And that's taken us a good 4 years to get there. But this is why we're here. This is the next phase. Stem cells have been around for a while. There's knowledge of what they're doing. But the reason we put them into our body is so we get cell factors at the end anyway.
Yeah, exactly.
So that's what we're introducing into your body.
That is actually a good point, right? So I don't know if everybody knows here or anybody knows here. But if you inject stem cells into a person or a mouse or a person, they will die almost right away.
They get trapped in the lungs.
They will actually die from, shear of being injected. And also because they don't have those instructions that Sanjeev was talking about. They find themselves in a very unfamiliar environment that they don't know what to do with. But before they perish, they produce all of those positive factors that you can just collect.
That's right.
So basically, there is no discordance. There is nothing to disagree on.
Yeah.
We can either use stem cells, they die, but before they perish, they produce good stuff for you, or we can just collect that good stuff, which is earlier than young blood, right? It's the earliest possible niche for organogenesis, for organ formation and organ repair. That is your embryonic environment.
That's right.
Except now we do it ethically, right? We do it in a very ethical, non-controversial way.
Wow, I don't think we
And I
can
didn't
top
prepare to
this.
say that. That was awesome. Yeah, I mean, I love you for saying that.
Would you guys like to go on to any more topics, or do you want to take questions?
Yeah, we take.
We want this to be interactive.
I want him to draw this conclusion because there's a lot said there, right? So a lot of criticism was around when stem cells, people were doing IV stem cells because they said, well, they get trapped in the lungs day one, and most of them die there. But she pointed out that they release these cell factors. So it drives healing, even though that many of them get trapped in the lungs. So it doesn't make it irrelevant. So I hope you understand that. That said, the question I have that I want him to answer for you, there's still a place for stem cells, especially in older people with a lot of degeneration. Explain that so people understand the difference.
100%. So like when you can't signal to something that doesn't exist. So if you don't have tissue, if you have no chondrocytes, then you can't signal to those. So you need engraftment. So it's a perfect opportunity at that point to have live cells in that space. And it's a combination. It's closed loop regeneration at that point, which you're going to hear more about after the World Health Conference in Dubai, because people are going to be talking about cell factors with live cells together, priming your body with cell factors, so your native stem cells open up. Then you're adding live cells, whether they're Muse or umbilical cord or Warren's jelly cells, to stimulate that tissue growth, and then signaling back to them so that they actually express post. And so that closed loop regeneration is going to be announced in Dubai in February 9th through the 12th at the World Health Conference, and it is going to be something that, and they're talking about quantum regen therapy, RegenQuantum, and our cell factor product. Because that's the product that we're going to be talking about in Dubai in a couple weeks, So that closed loop regeneration system is something that Dr. Pompa, that's exactly right.
Okay, first question.
Hi, I'm Dr. Sejal Patel. Just had a question to summarize what it actually is from what you said. So you're taking from one particular donor placental cells, and then basically they're being clonally expanded, and then you're taking off. Basically, like
there's no expansion.
The milieu. Okay.
So so we're taking there's 6 regions of the placenta, like your chorion, which we don't talk about a lot, your DP area, the deciduous area, the umbilical cord, the Wharton's jelly, the umbilical cord blood. You have to put these are all the things that grow a baby. So when you're a zygote, your cells signal for 9 months to give you eyes, ears, lungs, tissue, bones. And it's a cell signaling process. That's not an addition of cells. It's cells signaling to each other, and then they start replicating, right? Those cells start replicating when you signal to them because they're surface membrane. So we don't expand cells. We let them signal natively. It's a hypoxic environment, which is similar to what you would have in the womb, and that stresses the cells to secrete. And when they secrete, we isolate that secretome. So it's an isolated secretome. But
if it's from one particular donor, then how does it continue to proliferate?
You cryopreserve the cell lines, and you suspend them in the air.
So when you take on cells, you need a lot. You have to take 20 million and make them 200 plus million, put them in an IV for them to matter, right? Because you're expecting them to release the cell factors. But when you're collecting the cell factors, then you don't need the expansion because you have so many cell factors. And I don't even know. I mean, how strong you could make it and where that, where's the limit?
We don't talk about cell count anymore. So we're trying to change the dynamic of saying like, oh, I'm getting 200 million cells. Well, I don't give a shit about your cells, to be honest with you. How many cells that you're putting into your body? I want to know what the cell inside the cell is, because what's inside the cell is what you want in your body. You're putting exogenous cells into your body from someone else, right? And then you're hoping that they excrete all these things that Irina was saying and talking about, and that they're effective. But why are we doing that, right? When at certain cases we do, because we need the tissue engraftment, but really the product is what it secretes at the end. So instead of indirectly doing it, you're directly putting in the cellular signaling molecules to signal to your cells natively.
Next question.
Hello. I'm an interventional pain doc who does specific joint injections and spine injections for patients. Can you speak a little bit more to how the product kind of activates an umbilical cord derived product when it's injected intra-articularly for a shoulder or a knee to help with soft tissue repair?
Yeah, so I'm not a clinician, but I will speak to, it amplifies the Wharton's jelly, right? Wharton's jelly in an MSK injection or an umbilical cord cell, it is going in there as scaffolding, right? So it's holding it locally to there. It's keeping the injection local, and then you're increasing that amplification with cell factors, right? So you put the Wharton's jelly in as a scaffold to keep it local. It does have healing benefits as well too, and it's doing that. And then you're increasing and amplifying the effectiveness of that Wharton's jelly when you do the MSK injection. Yeah.
Next question.
This is somewhat facetious, but not really. So I know that she's 18, healthy, no COVID vaccine, all that, but there's so many sources of placenta around the world. What if the father is like a 70-year-old sugar daddy. Does it matter what the father is?
I mean, he wasn't, but they were both young. The baby was a mistake, to be honest with you. It was not. But I'll give you it was a girl that was born. So sometimes from a cultural standpoint, that sometimes matters for some people as well too. But really, the placenta takes away all that. Like, it holds DNA.
I'm gonna say,
and there's no DNA in the product. So you're only looking at it from a cell signaling standpoint, not so much a DNA standpoint, right? So you're not putting DNA into your body, and that's the best. I think, in my opinion, culturally Indian, I don't want someone else's DNA in my body. I don't. I think that's bad karma. I think that's not good. You carry 9 generations of health and of others and their weight. So, like, spiritually, that's just not. That was one of the driving forces behind the product. Is how do I get what I want out of this without having to put live DNA into my body?
All the sugar daddies like that question.
Go to Dr. Ash. He'll help you out.
Hey, we got one more question. Another question.
I'm going to set up. Hold on. I'm going to set up Irina here because I asked the question about plasmapheresis. I said, well, wait. So if you take off your plasma and then you get young plasma, right? Transformative. And this was a lot of her work. I said, well, what if you get not so healthy 18-year-old, 22-year-old? Because there's this sweet spot, like they 18 to 20 some, that they love that plasma. And the answer surprised me. It was, well, the health of them really didn't matter in the studies that they did as much as the age. Because the so meaning, like, wait, you could take someone who's unhealthy, their plasma, as long as they're young, the study showed that it didn't matter. So build on that.
Yeah, so first of all, we don't need anybody's young plasma. And this is a very cool point. And it does not really contradict other panelists here because we have many, many ways forward and we don't really know how to cure aging yet. But all of these young genes that Sanjeev was talking about, they did not disappear from your genome. They are in every cell. You still have them. What happens is that they are inhibited, they are blocked from making those good signaling proteins by age-elevated, over-present, excessive, transforming growth factor beta and other inflammatory proteins. So you basically have excess with age. Once you dilute them, once you basically flush them out of your system and simply replace them with saline, which is salt water, which is kind of the liquid you have in your body anyways, and albumin, which is the major protein that you lost when you removed all of the aged plasma, you start producing those young signaling proteins again, even when you are old. And of course, when we add more from placenta, you will be even better. Those will act stronger, and particularly if you have arthritis, they will act better there. But for kind of general maintenance, we don't need anything young. We have everything young already, but this young is being blocked by the age-elevated proteins. On a related topic, why do you have those proteins? What if you simply turn them off? Well, if you turn them off, you will not be even born because they are critically needed for you at the healthy, young, low levels. So when you are young, their level is here. When you grow old and your tissues are constantly damaged, the level is over there. When it's over there, it's counterproductive for you. When we simply dilute them, you start rejuvenation. When we add stem cells, we add additional placental factors, you might rejuvenate stronger or you might actually recover from the disease you already have. That is my current understanding of the whole process.
Yeah, I hope you all see where we're at right now because it excites me. Sabina, the esthetician, where are you? Right here. Our conversation, right? Skin, when you transform people's skin, it's from the inside more even than the outside, but both, right? That's what we're able to do here. We're able to do these cell factors and transform what's happening on the inside. And then we're able to actually even use them on the outside. You know, we are in a new place that I hope that this is going to take all the things that we're seeing now, the Botox, the fillers and everything, and I hope it puts it in the past. And I believe it will. We had the conversation. I do. I believe that this is really going to slow down the aging process in a big way. And here's the most exciting thing. The criticism that I always get, I refrain from talking about stem cells on my social media because I get criticized. I can't afford that. No one can afford that. I appreciate that. This is different. This is taking something now for the first time and bringing it to the average person who is going to be able to utilize these. And the price is only going to come down. I mean, we're early on. But that to me is the most exciting thing because I see so many people that need this. And now they're going to be able to first time that they can't run and get 200 million stem cells, but they're going to be able to do this from the outside and the inside. It's exciting.
I love you for saying that because that is the vision, the goal, and the mission for our company is to, democratize the space. We are creating a place where $150,000 is not available for everyone to get stem cell transplants, right? For everybody. You can't just fly to, Mexico, Costa Rica, Colombia, or go to some clinics in Florida and Utah now. That is not reasonable. It is not reasonable. There is no longevity and sustainability in that space if you do that. Cell factors, if you start taking them early enough, as you start to signal out, are preventative youth signals going into your body to prevent that aging process from happening originally. And they are affordable because we can suspend them. We can cryopreserve them. We can make 50 years worth of product through them, right? So we start entering our system before we start getting sick, right? We start preventing that aging from happening. We start preventing that from going down so that we aren't looking for answers after we have, kidney disease or after we have, a serious heart attack or an injury that is, debilitating to us, right? And we can't recover. And then we're looking for solutions. That's kind of my reason, right? And so we introduce these in the beginning when we start aging, that signal is around like 28, 29 years old. That is going to prevent us from aging as greatly as we are. Yes,
it's actually awesome. No. It's awesome that you said 28, 29 years old because when we actually quantify the real biological age, right, by looking at the biological noise, guess when do we have the sharp increase in our age? It's not when we are 50, it's when we are 28, 29. And like it goes when we have very, very low biological noise, we are young, sharp jump up. Then healthy and short-lived plateau of adulthood, very short. Then biological age goes way up again, and we have all of the diseases. So when people start rotating out of the Olympic teams, now Olympic Games are soon to start, this is when we have the first aging. And if we could offset it, even by 2 years, it will be tremendous economic advantage, tremendous, health, quality of life advantage for everybody.
Right.
Absolutely. It's amazing.
Next question. Please refrain from talking to one another. You can talk after the show while they're on the panel. Please be respectful. Next question.
Sally.
Hi. I just wanted to know, how would you explain something like this to somebody who's not already pre-educated on it?
Say it again.
How would you introduce this to somebody who's not already pre-educated on it?
Kate, I want you to have a stab at that because you've been communicating this for a while.
Okay, cool. So you guys have all heard of a stem cell, right? I think that's kind of normal language now. So we also know exosomes are extracellular vesicles that come from stem cells. So that's sort of like one step down. And then we're just looking at cell factors as the innovation from exosomes. I think that's the most simple way to explain what it is. It doesn't mean that you have to only do cell factors and not you can combine them. We talked earlier about how they can be synergistic, but you can also just take cell factors and use them with other modalities or with your own natural innate intelligence.
Okay, next question.
Thank you, Dr. Pompa.
Thank you all so much. Very interesting talk. I'm a dermatologist. I love bringing new things like this into my clinic, but patients will always ask me, what is the downside? What are the adverse effects? What do I have to watch out for that's a negative? Can you speak to that, please?
Yeah, and in cell factors, which is really cool, and that makes it different from stem cells and exosomes themselves, there is no variability in them, right? Because they're batch and lot number specific. We give you the certificate of analysis. We tell you what it is. Injection site risk is always a situation. We've seen people get tired. Especially if your hormones aren't optimized. So we've seen some people get tired when they do systemic injections. And we've seen some people have a minor headache if they're not hydrated enough. But other than that, your body receives them as native. because it recognizes the communication. It is a natural signal to your body. Your cells aren't going, what is this in my body? They're going, where the hell have you been? And that's the difference. And so it's an instructional code that we've had. And when we were kids, they were very rich in those signals. And as we aged, they've gotten less rich, right? And so now we're introducing them back into our bodies, and our cells they're happy about it, right? Because they appreciate knowing what to do. That's their job. And that's what they've forgotten how to do, or they haven't been signaled to do it in a long time.
For generation lab test, right, it could be upsetting, right, if you know that your actual age, biological age is higher, or you have certain problem in the system, but it is actionable item. It's kind of, if you want to lose weight, it might be upsetting to look at the scale number, but it is healthy for you because then you see the positive effect of the diet and exercise. The same thing for generation lab biological age test. You can act upon it. So while psychologically it might be unpleasant to know, but then you go to the specialist or your primary care clinician, and then you can solve the problem because we have so much more medicine before the disease is in progress as compared to when it's full blown.
Next question.
Hello there. Question is, I have two questions, but they're pretty simple. Okay, one question. Okay. If I had to pick, what's new and exciting in regenerative medicine coming over the next 3 to 4 years that we could get excited about?
So we have generation 1 drug, which is longevity therapeutic, that's supposed to reverse biological age of people who are already old and frail, and certainly of people who are not already old and frail, starting from about 45 years old and maybe up to 75 years old. And it is based on 20 years of Conboy lab research. It actually deals with those age-elevated proteins that prevent your own useful genes and proteins from being present and acting. That is our goal, to put it in clinic and hopefully in people in 2026.
Next question.
So, Sanjeev, they're talking about cellular efficiency through your cell factors, right? How quickly are you noticing with the testing the changes and like the biological versus the chronological aging?
So something really cool, I'm glad you asked that question. We're seeing changes in 30, 60, 90 days. We're measuring them in 90 days. And so that's kind of like the standard that we're talking about. And they make a huge significant difference, right? So the cool thing about Generation Labs test is you can see the effects of the therapeutics that you're putting into your body. And so that part's amazing. So we're doing a cool thing this week at the Super Bowl where we're going to be testing 100 Hall of Fame players that have been a part of Hall of Fame Health. We're sponsoring launching that partnership this weekend, where we're looking at guys like Mike Singletary, Ronnie Lott, and we're going to measure their generation lab test in the beginning. We're going to treat them with cell factors and see the injuries that they've had. These are guys who have collided and caused most injury to their bodies like no one else, right? Especially in the 80s and 90s, and they're lived through that. And so we're going to measure that biological age on the forefront, and then we're going to treat them with cell factors. We're going to be talking about those publicly. They are going to be talking about it publicly, and their scores. So so I'm glad you asked that, Dr. Adam, because I think that's super valuable and important. And we're looking at it about every 90 days.
Okay, so I just want to say I did this test, and I'm 61, but it said my insides are like 70 and 74. I was an athlete. Give me some slack. I'm going to give the microphone over. Can I, with cell factors, get back to me in 28 years old?
So I'm going to say no, and the reason is you've had 40 years of not being 28 years old, right? And so that's the hard part. You have to reintroduce these messages. Is it going to fix things? Yes. Are you willing to take 4 to 5 vials a month for the next 10 years? I don't know. That may be a possibility. But what you can do is you can see a reduction or a slowing in that process and bringing it back. That's exactly right.
You will see a reduction for sure.
I don't need a reduction, brother. No, all right.
28.
The joke was there. I had to go with it. All right, next question.
So I've had a kidney transplant, and I go with Dr. Pompa to get stem cells in Mexico, and when I do exosomes, I can just inject them, but stem cells I always have to take like an antihistamine and other things to prevent a reaction. With these, do you have to do that? Is there any prep, or can you just inject them and not have an
so
issue?
with cell factors, you don't have to worry about like that injection risk, like that immunogenicity response that you have with live cells, because they're native to your body, right? And so you recognize them. But the big thing with what you're doing, and stem cells in your circumstance are great, you need to prime your body to receive the cells that you're going to be receiving, and then you post cell responds. So you put cell factors back into it, so it stimulates the growth, because all of it is cell signaling. Once the tissue once the transplant of the stem cells engrafts, it has to release exosomes, it has to release those cell factors, right, into the body for it to work. And that takes time. But if you start signaling to them, you're going to get a higher engraftment rate. So if you're doing 200 million cells and you're getting a 3 to 5% engraftment rate on that stem cell infusion, and then you got to wait for that 3 to 5% to excrete exosomes and then secrete the secretome. That's the efficacy of that. So if you prime your body first to open it up to receive, so your cells are turned on, your native cells are turned on, you can increase your engraftment. So you can take your 200 million cells, and instead of getting 2 million of them engrafted, you might be able to get closer to 20 million engrafted.
Yeah,
Next
so
question.
That closed circle that he's talking about, especially for people who have more damage, the older you are, means even more. So you do the cell factors first, and then you do the cells, and then you do the cell factors again. That's that whole closed loop.
Next question.
Time for one more question.
Last question. Okay.
2 more questions. Yes. You get 1 and 2. We got it. Good.
Wait.
Oh, wait. Oh, you go first.
I'll go first real quick. Sanjay, my question's easy. Thank you for what you're doing. I think it's great. I love the democratization thing, because I think that's, a lot of the issues around some of these longevity healing things. I mean, I think that's going to be really good for your business, but it's also good for society. Question about peptides. They're all the rage. Give us a quick explanation of this. When you say cell signaling, that's what peptides do. Are there any peptides that do something similar to this, or how do you compare it to peptides?
I mean, peptides are cell signals too, right? They tell our bodies how to signal. They're just direct cell signals, right? There's a single cell signal to tell the body how to repair. So like take BPC 157, it's telling your body, oh, I need to have tissue repair. This is what's happening, right? And that's how it's just one cell signal. But that cell signal is not, if you take it too much, it attenuates, right? And so you have to pause so that your cells so they stop seeing the same signal coming at them. If you take like a cell factor, which is like a kind of, we call it a global reset, right? And so like you're looking at the cells, you're signaling to them, and then they start to open up and respond, you can get your back on your BPC 157 faster, And so peptides are cell signals, they're just direct cell signals. And this is more of it's a cluster of information that's being signaled to.
You didn't. One thing you didn't explain. I'm sorry. Yeah. Are we done? She's got to go.
No, one last question. We saved the best for last.
Give her a round of applause. Thank you.
No, we got one question, so we're gonna go.
Amazing work. Yeah, very promising.
So is the how many of the factors?
Yeah.
Okay, she was worried about her leaving.
Okay,
We can take a
so
few more.
how do you navigate the FDA approval on human placenta when most of the companies that are doing stem cell creams or stem cell moisturizers programs are using vegan placenta as opposed to human placenta?
Yeah, most of that's crap, though.
Yeah, so I won't say that.
That may be the case, but that's not my question. Is not whether they're crap. My question is, how do you navigate the FDA approvals on stem cell from human placenta?
So we're FDA registered, so it's a 361 laboratory. It's minimal manipulation. And the thing that other exosome companies and stem cell companies don't do is they don't take the extra 3 steps. So if you want to have a registered laboratory, if you want to be forward facing, if you want to tell the universe what you're doing, right? You register your laboratory, You get the accreditations with the American Association of Tissue Banking. You tell people what you're doing, and then you say it. You show them the process and the methodology. Because I'm not in a whisper campaign. I'm not trying to hide, right? All these other laboratories are hiding. Oh, please use this over here. And how we do it is because we let it excrete and then we wash it. And it's acellular and it's DNA free. So even though the source material is placental, if you take it, there is no placenta in it. There's no DNA in it. There is no cells in it. It is only the signal. That's different than a vesicle, which is the exosomes that are on the market. That's different than cells that have live cells in there that are there. So, like I said, we are first in class in this space. This is a launch to tell everybody we're not hiding. We're telling you this is what's going on, and you can do it this way. You can get conditioned media from any laboratory in the country, but it's not. It's derived and it's also expanded, right? And so conditioned media is not good. In those, it's not native. I shouldn't say it's not good. It's just not native, right? And so you have the ability to heal. You have the ability to do all those things. That is derived from a source that is the placenta, which is regenerative. And then you can isolate it out to be DNA free and acellular. And you use 6 different bioreactors to suspend the signals, watch them, bring them into a medium, not a conditioned medium, but a medium. And then you put them together. And you're allowed to do that because it's a single donor versus multiple donors. And then you can increase the protein concentrations, you can increase the cytokine concentrations, you can increase the chemokine concentrations to have a really potent 99% bioavailable product upon injection. And it's the doctor's choice to inject it, you know?
All right.
That makes
so
sense?
thank you guys. So for the sake of everyone, not sitting forever, they'll both be here if you want to come ask questions. Do you want to also tell them where they can find Cell Factors in LA?
Through Dr. Oh yeah, we do them at Beverly Hills Rejuvenation Centers. Obviously, they're there, so that please visit us there. But also, you can go to regentherapy.com and you can start the process. If you're a provider, it's provider driven. It's not direct to consumer. So you have to be a physician, you have to be a provider. We want to educate the providers first and have you guys educate our patients versus the other way around, which is happening a lot. So that is the idea of being it provider driven all the way through.
Fantastic. Well, thank you both so much. And thank you everyone for listening. And please come ask more questions if you have them. And thank you.
Do anything for you. Do anything, anything.